Hi everyone, let's talk about linked list today. We will be discussing beginning addition, beginning deletion, and end deletion. So first of all, this is a class node. You can have any name for your class in the exam. I have taken the name as node. Okay, it has two data members, int data and node ADR. Now you must be wondering what is node ADR. It's not exactly an object. It's called a pointer variable which points towards an address or a memory location in the computer. We have made the constructor, default constructor, data equal to 0, ADR equal to null. Now first, let's talk about a function, beginning addition. Beginning addition. Okay. First, let's discuss the concept of beginning addition. So this is a starting node, for example. Starting node. Okay. First node. For example, the address is G720. Over here we'll store the address, and our data, that is the value, is stored in the node or the link, is 19. Further, the next node is 7, 8, 20 and 5, and further we'll go on like this. Okay, now we need to add a node just in the beginning. That is, this is a starting node. We need to add a node over here in this place. Now we need to think of an algorithm to do so. We only need to make functions in our exam, not the main class. So let's try to generate a function. First, let's think about how will we achieve this through a code. So if you want to have a node over here, there can be two conditions. If your linked list is empty, that is, there are no nodes over here, then we'll check if start equal to null. If it is so, then it will be very simple. We will have start is equal to whatever node you have made. Otherwise, we need to think of another scenario so that this thing becomes, the starting node becomes the second one, and we are able to add over here. Now let's begin with our function. Public void badd. I will be calling my beginning addition function as badd. It will have two parameters. Since our linked list contains integer type values, so I will have my first parameter as int value, which will be val, which will be entered by the user. And second, I will make a pointer variable, a node. Sorry, node is the class. Okay, so I will be making a pointer variable over here, node start. This variable, or this will point towards the memory location which contains our first node. Okay, we need to create a node over here, an object over here. So let's begin. Node, I will be calling my object or the link which I need to add over here as nptr. You can call it anything. We have a default constructor, so we will not be having anything in our brackets. So it will be new node empty brackets. Then we know that in order to access a data member of an object, we need to use this dot. So we will be having nptr dot data. Whatever the user has entered, the user will be entering the data which is required to put over here in this thing, int val. So this parameter will take the value and we will be putting it over here, nptr dot data equal to val. And you can give any address to it. Since we don't exactly know how or what will be the address, how to actually write the addresses for a computer, so let's put our address as null. Okay, if start equal to null, then in the start position we will be putting nptr. Okay, start equal to nptr, and we will return from here. You can also use an else, but to keep the code simpler, I just return after entering into the if block. But yes, if you don't want to use the return keyword over here, then you can have if, then else, and then we can write the code further. To avoid blocking and getting confused, I just return from here. Okay, next part is, if your start is not null, then nptr dot adr will be equal to start. This shows that that this address is not actually pointing to the current object's address. It actually points towards the next object's address. So if you will make the next object's address as start, see, in the start position we have this right now. So if you write this code nptr.adr equal to start, then the next address which will be coming after this nptr will be this G720. Okay, therefore nptr.adr equal to start, and our starting position will be equal to nptr. we'll now close this statement, and here is the ending of this function. So this is how we will create the function for beginning addition. Now let's come to ending addition. That is when you will be adding a node towards the end of your linked list. So over here we need to traverse through the linked list. I will be talking about traversal in detail in another video, but let's get a gist of it. Okay, so this is your linked list. Again, this is the address, this is the data, ADR, and over here we have the data. Over here we have the data. Okay, again our linked list will continue 7A25 and so on. Now after the last link we need to add our node over here. In this position our node needs to be added. Now we know, unlike a for loop where we know, or an array where we exactly know what our end position is, because so in an array, we know that the memory is very specific. If we have created a memory as 4 for our array, then it will be, we can't change it. But in case of linked list, we keep on adding the memory. So over here, we don't know the location of the last link. Therefore, we need to traverse through the entire linked list. That is, we need to go to the first node, then second node, then third, and so on. And then only we can reach over here. So in order to do so, we need to create a for loop which traverses or goes through the entire path. Okay, so now we'll create a for loop method for it. Okay, we have public void, I will give it eadd, the name, then int val will contain the value, then node start will be the address of the beginning node. Again, we will be creating an object as node nptr equal to new node. Node is the class, by the way. Again, we need to put the data in nptr.data equal to val, and nptr.adr, again we'll put it as null because we don't really know any other address. Again, we will have the condition to check if our linked list is empty or filled. Therefore, if start is equal to null, then start will be equal to this object nptr, and we will, okay, now we will have the return keyword over here. Next, now we will start the traversal. For this, we will be using a for loop. We will create a pointer variable node I. This will begin from start, the first node, okay, and we will continue this I variable till I is not equal to, I dot adr is not equal to null. Now why we did this is because we will actually keep on checking. Okay, so regarding the working of the for loop, this for loop will begin from node I equal to start. Over here, the node I is not an object exactly, it's a pointer variable which points towards a memory location in the computer. So now we will begin the traversal. Now this loop will run till I.adr is not equal to null. Now we know that I.adr points to the next memory location. So if our I is this node, then adr will point towards the next node. Therefore, if we reach the end of the, and if we reach the end of our linked list, then we will know that if our node will have its next node as null, therefore we are at the last node. So this is how the traversal will work, and we will keep updating this by putting I equal to I.adr. Now once this condition becomes false, we'll come out of the loop. Okay, now this loop will not have any body. I'm not doing any blocking, so I have added a semicolon over here. This loop will just run itself over here and just traverse the I towards the end. Okay, now one more thing, I think we will not declare this variable inside the for loop. We'll declare it outside. The reason is because we need to use this variable outside the loop. Now once we have traversed, we know that I is probably not probably, but it will definitely be at the second last position of the linked list. Okay, so therefore if we need to add something in the end, we will write I.adr equal to nptr, and this is how we will add a new node towards the end of our linked list, and this is known as ending addition, and we will end our function over here. Thank you. Okay, now we'll be talking about beginning deletion. the concept remains almost the same, but over here we will be removing the first link from the beginning. So if this is a first link, we need to remove this link from our linked list. Okay, the concept is very simple for this one. We'll straight away start with the writing of the method or the function del. So over here we don't need to add a value, so we will only be having only one parameter over here, node start, which will indicate the starting node. We will again check if there is the existence of a linked list or not. If start is equal to null, then we will print a message, system.out.println no linked list will be the message. Okay, we will return from here. I prefer not to use the else because then we will have need to add blocking over here. Next up is, if we don't return from here, then it's very simple. Start will be equal to start.adr, and therefore our function will close over here. So basically what happens is that in order to cancel this, what we do is the starting node will shift to the next node, because we know that start.adr will contain the address of the next node. So start.adr is this node, and if start is equal to this node, then this node will be ignored completely and we will come over here. So this will be the starting node now. Now let's talk about ending deletion now. Okay, ending deletion. Okay, ending deletion is the most complex out of all them, but it's not so complex. So let's start. So the concept is, again, we need to traverse over here. We will keep on moving from one link to another as we moved over here in ending addition. So we move from this link, then this link, then this link, and we will need to remove the last link now. Okay, so first, as always, we will check if our linked list is empty or full, or it has something in it. We will create a method or a function called public void del. Okay, the parameter will be node start over here. If start is equal to null, then we will be printing the message system.out.println no linked list, and we will return from here. Otherwise you can use the else statement as well. Okay, now comes the real part. We will need to create a pointer variable over here. First, for traversal, I will again make a pointer variable node I outside the for loop, and another pointer variable, okay, object node prev will be created. I will just assign it a random value, start. Okay, now let's start our loop for traversal, for loop. Again, we'll begin by I equal to start. This will again run till I.adr is not equal to null, and updation statement I equal to I.adr. Okay, now this loop will have a body, prev will be equal to I. So every time this loop learns moves from one node to another, we will store the value in our prev, which is a pointer variable, as prev equal to I. This will store the address of the node we are traversing on right now, prev equal to I. So once we reach the last node, okay, we will reach the last node, because we know that the last node has no node after it. So I.adr for the last node becomes null, and once it becomes null, we will not enter over here, and prev will be equal to I, which will be the address of our last node. Actually, second last node, okay, because we will not enter the loop once we reach the last node. And now we will write prev.adr equal to null. So this will completely strike off the last node from here, and our last node will therefore become the second last node, and this way we will delete our last node, and this is how we do end deletion. So these were the four functions. We will discuss linked list more in detail, but as of now, this is what we require for exams, these four functions. Thank you, everyone.